one of the problems is that you want to reserve. So if you think about like how you deal with the cloud, you can have like reserved instances where you reserve some number of like nodes for just yourself for a 1 year period. Or you could also have spot instances, which you just like spin up and it just like runs for some time. And you want to mimic that in crypto. The spot instances already exist. Like you can just buy bandwidth or like compute on the fly on Ethereum on any blockchain. EigenLayer is the first one that offers reserved data bandwidth. It means you come in as a rollup and say, hey, I need like this much bandwidth for this year, and there's some pricing associated with it, and then you just pay for it. Now you have a contention-free access to that data bandwidth. Nobody else can write data in that space. Only you. It's just for you. And so that means now you have guaranteed fee certainty. So the next 1 year, this is your price, this is your lane, no contention. Yuga Labs cannot create a new Bored Ape drop and like drown you, or CryptoKitties or whatever the new version of that. Not going to happen. You have your own thing. I think this is really, really important.
This is Sina with another episode of Into the Bytecode. My guest today is Sreeram, the co-founder of EigenLayer. In this conversation, we zoom out and think about EigenLayer as a system and its implications for crypto and the web more broadly. Specifically, we get into how Sreeram thinks of rollups as a new kind of verifiable web server, and AVSs, or actively validated services, as an analog to SaaS in this verifiable web. We work through the different ramifications of what this could mean, what it means to use a rollup as a web server, what the underlying economics of them look like, and how to think of AVSs as services that cater to these web servers. I think some of the ideas we talk about here could have far-reaching implications and influence how we think about crypto applications going forward. I also want to say that this podcast is for informational purposes only. It's not financial advice or recommendation to buy or sell securities. And with that, I'll leave you to it. Into the Bytecode is sponsored by Privy. One of the biggest problems we're grappling with as builders working on crypto-enabled applications is how to make the right trade-offs between user experience on the one hand and security and privacy on the other hand. How do we promote self-custody and ownership while letting the application shine rather than the crypto behind it? So Privy plays an important role here. They provide simple onboarding so anyone can connect to your app easily by allowing them to sign in with an existing wallet, or by making it easy for you to provision a new self-custodial wallet for them, linking to social logins like Google, Twitter, or Discord. I personally have faith in Privy because of the team. Henry Stern, who's one of the co-founders, was previously on an episode of this podcast, so you can listen to that conversation for more of a deep dive. And he and his partner, Asta Lee, have been thinking about data privacy and security for a long, long time. And you can see this in the level of thought they're putting into the product. So if you're working on a new product and thinking about how to reach a wider group of users without compromising on either user experience or privacy and security, then I encourage you to check out Privy at privy.io.
And that is actually like a pretty high bar, in the sense that if you're a builder, you kind of say no to pretty much most platforms because you're taking a lot of platform risk. It's not an easy thing to convince people to say, I'm going to give you like a little bit more incentives, come and build on us. Like, it doesn't work like that, especially when the whole thing has to be thought about from first principles for building on a platform, because no such platform exists till now. So I did not expect in 2024 we would have AVSs. This is just like the fact. I thought it'll take at least another 2 years to have third-party AVSs come and build on top of EigenLayer. It's not easy. It's very difficult to build it. You have to build it. Right now on mainnet, we don't have slashing. So they're building AVSs, hoping that as they build and expand, we will be building and expanding our own like slashing roadmap. And this is a lot of trust. And that's and one reason people do that is that it unlocks something that is not possible otherwise. Right? The alternative for me, if I'm building an Oracle or a bridge or any of this stuff, is to just like start from nothing. Like, at least here I'm getting something. Like I'm getting trust. I'm getting some set of like resources. So that makes it possible. The other thing that we found, which is really interesting in the AVS economy, is some AVSs are only possible because other AVSs exist. So it's just like a flash loan is only possible because you already have, a swap and some other things ready. Like then, you can bundle them together into a flash loan. It's kind of like that you can create an AVS because other AVSs exist. So now, like, to actually create this AVS economy, you not only need to have, just come and build this one AVS. No, you have to actually create an economy of all AVSs so that like each AVS can specialize. Because what's happening is, the way I think about it is super specialization of builders building very niche services. So I can build a niche service only if other niches are all well served.
Yeah.
So that it's a kind of like a sustainable economy.
Yeah.
So
maybe let's take this kind of transition into you had this tweet, I think, a few days ago that packed a lot of information for me. And it was this kind of framing. It's like almost it's a crypto native poem of some sorts. Ethereum is the verifiable internet. Rollup is the verifiable web server. AVS is verifiable SaaS. EigenLayer is the verifiable cloud. So can you explain what you mean by this?
Yeah.
And this is a big topic. We could spend a long time here.
No, I think it'd be really awesome to go into it. It's a kind of, to start with, I think I'll start with the one thing that I knew like 3 years back, which is when I looked at like the whole crypto economy, one of the things that was striking is what I call the separation of trust and innovation. And the idea is that, Sina and I were just talking before the show about anonymous developers, right? And anonymous developer is a really interesting concept, and a service which is run based on code written by anonymous developers is a really, really interesting, and especially services that need a lot of trust, right? Like a financial protocol, like Bitcoin.
It's an oxymoron. Like how could something like this be even possible?
It's such a crazy, it's a crazy thing.
And that the biggest of them all, that Bitcoin has this property.
Yeah. And it's because trust is supplied from some other place and innovation is supplied from some other place. Like, and this is particularly true of smart contract platforms where I can create an innovation, like I write a new Uniswap, and then I throw it on top of a blockchain. And the blockchain underwrites trust into it because as a user, I don't need to know who wrote the code. I just need to trust that the blockchain will continue working correctly. Then I can, don't need to know who actually created this particular piece of software. So this is a very, very powerful revolution, right? Like the separation of trust. So I call this the separation of trust and innovation. And to make an analogy, I think we can think of the separation of capital and innovation, which is different people bring capital and different people bring innovation. It's only 60, 70 years old. And a lot of modern technology is only possible because this market structure exists. Which
you mean the kind of like the venture capital industry or the C corporation?
The venture capital industry is the C corp is another like manifestation of like public money going into like a common enterprise. And this is particularly this idea of the separation of trust and the innovation and capital unleashed so many things, because otherwise people who had ideas like myself, would simply not be in a position to really build anything, because you need double coincidence that the person who has money also needs to have a good idea. And a lot of, I would say, like civilization is unbundling these things, right? Like that's what progress in civilization is, unbundling it so that I just need to have one dimension, somebody else.
It's like creating a market around these things that were bundled together.
A coordination mechanism, a market around it to actually connect these different entities to then like work together. And the separation of trust and innovation is at that kind of foundational level in my thinking, because now somebody else brings trust and somebody else brings innovation. And this was like a fascinating kind of concept for me to think about. And this was kind of my routing theory of what is going on in blockchains and why they are actually interesting. Because I was seeing, like many of us in the space have, that people all around the world can contribute as equals. And, without age difference or gender or anything, like, people say, do not discriminate. And in some sense, in blockchains, you cannot discriminate. Like you don't even know like who's on the other end of this. It's a very powerful kind of a framework.
It's also interesting you could almost think about ZK through the same lens also, right? It's another technology that has a similar affordance.
Yeah, the ZK, in my view, breaks the privacy verifiability trade-off, which is a fundamental trade-off in society, right? Like in culture. How do I prove to somebody that I did, I'm doing something without actually revealing all the details of all the things that I'm doing all the time? And, ZK is like, broadly cryptography, but specifically ZK has this like crazy thing where you can actually separate the verifiability, maintain privacy while maintaining verifiability of certain covenants. So absolutely. I think these are such powerful unlocks, and I think as a broader community, very little of this is understood. And particularly, I was seeing that if permissionless innovation is the main thesis of blockchains, I, as a builder, did not enjoy the benefits of permissionless innovation. What do I mean by that is because we were innovating at the level of consensus protocols and so on.
Right. So you couldn't just deploy a smart contract on Ethereum. And you needed another way to tap into this decoupling of trust and innovation.
Exactly. I didn't have a way. And I was kind of felt bottlenecked myself that, hey, I can't do it. And I looked around and I saw basically all deep infrastructure developers in crypto were basically in the same place. They were building these hard, really, really hard and important things, which were basically the bottleneck for the entire space. But they didn't have a decoupling of trust and innovation. They were actually just sitting at, I have to go and work at Ethereum Foundation or maybe Solana or Avalanche, like 3 places. Right? Whereas if you're a smart contract developer, you would say, go work at one of 1,000 dApps or start your own dApp. You don't need to even ask anybody. So the scale of like freedom and like ability to do things was completely different as a smart contract developer versus an infrastructure developer. And so
what do you see as the key difference there? Because let's say, an Oracle or a Bridge or, certain protocols that I think could be implemented as AVSs. There are currently implementations of them that exist as smart contracts. And you basically get whoever the parties in this protocol are to play a crypto economic game as mediated by this smart contract. So they have to deposit stake and they get slashed based on certain conditions. And, DeFi protocols have to do the same thing, right? Like it's, so do you think there's actually a distinction between infrastructure and applications if both of them are kind of leveraging crypto economics in some way?
I think the line that I would draw is validation as a core task, like somebody running a bunch of off-chain software and then bringing the outputs of that on-chain is fundamentally very different from DeFi risk, right? Where you're basically underwriting a bunch of price risk, right? You're depositing money into an Oracle or depositing money into a lending platform or a Uniswap or something, you're actually underwriting some series of price risks, right? Or taking price risk yourself. That's what you're doing. Fundamentally very different from things like bridges, where you're like depositing money to actually do validation tasks. So you absolutely right that you can build these as smart contract systems, but smart contract is not the only part of it. Like you have to actually create a group of validators who are off chain, and then you have to do this job. They have to be decentralized. They have to have enough stake, and all these things put so much friction that what I found is these kinds of middlewares, and like Oracle is a great example, usually just concentrate to one player and nobody else. It's not like that the one player has the best ideas. They may have really good ideas, but other people may have also really good ideas, and they simply have no place to express it other than to go and join at them, which is not true of other there's much more permissionless innovation in all the other like dimensions, because you're not also facing a trust bootstrapping problem. Because when you run your own Oracle, you're like, oh, what are these nodes? Do I trust them? Do they have enough collateral? Why would I put my collateral in this thing? Like all of this together basically creates like a starting entry barrier. The entry barrier is so high that it's difficult to not to get started. So the line that I draw is everything is at the end going to be, expressed back into smart contracts. Even EigenLayer services, bring answers back into Ethereum smart contracts or L2s and so on. So that's how it is going to be. But the question is, can I tap into an existing pool of stake, an existing pool of operators? Can I just, in the ideal world, a developer would just write a code and then throw it on top of a system. The system kind of figures out, oh, let me find some operators. Let me send it to them. Let me get the stake. Let the security auto scale. Let me make sure that this would be the ideal output, where the barrier for a developer to create the best ideas and the best ideas win is actually like much lower than what we see.
Yeah. Into the Bytecode is sponsored by Optimism. The Optimism Collective is building the open source modular software project known as the OP Stack, which allows developers to run layer 2 blockchains, while also addressing key governance and economic challenges in the wider ecosystem. Optimism is also leading decentralized grants experiments, like retroactive public goods funding, which recently granted 10 million OP to projects across developer tooling, infrastructure, and education. More recently, they had a major milestone by adding Coinbase's blockchain Base to also be governed by Optimism governance, and also contribute a portion of their sequencer revenues back to the collective. I've known the Optimism team for many years and know that they're dedicated to both scaling Ethereum and extending its ability to build better economic structures. So, if you're interested in learning more, whether you want to build something new or you want to apply for grant funding, then I encourage you to check out Optimism at optimism.io. I was thinking through, before we started recording, we were talking about TrueBit, which was a project I worked on earlier. And we had a kind of similar multi-sided marketplace where there were task givers, which were, and I think it's very similar to example AVSs that might exist in the wild. So we had a task giver who would create a task of like a program that they wanted to be run. That this was like usually a large program that wouldn't fit within the block gas limit. So you wanted someone to run it off chain and post the result on chain. And then there were solvers who would run that computation and post it. And then there were verifiers who would challenge them and get into this challenge verification game. And in that, like when you think about smart contract protocols like that, there is also a way in which that if the economics and the incentives of the system are well designed, it's possible in the abstracts to imagine that you deploy a smart contract And without doing anything else, this like ecosystem starts emerging around it. You know, that's like, you know, you could say that that was the case with Bitcoin maybe, or, but then in reality, the team has to go put in a bunch of like muscle to get people to, you know, build the implementation spec, the reference spec for the node, and get, you know, people to run it and incentivize them to do that when the network is small and all of these things. And I think today with EigenLayer existing, you basically like compress that entire, like you kind of shrink the space between an idea and that idea existing in the world by shortcutting all of this like operational heavy lifting that a team has to do. Because it's not only that you get the security, you also like, it's kind of it's like you get to tap into this peer-to-peer like network that's already been bootstrapped with a bunch of like competent, you know, high SLA node operators that are out there, and you just get to leverage them, which is an incredible thing.
Yeah, that's that getting to that end state where we compress it even more is really like our goal. So that's why we keep talking about open innovation as a kind of a core value. Mm-hmm. And when I was thinking about it, and you know, I know people in our space, including myself, had the tendency to say, "Oh, this cloud is too centralized," and all that stuff. But one thing I did find in the cloud era is there was a massive amount of open innovation unleashed due to the whole software as a service era. And why do I say that? Like, you know, if you were building an application in like 1995, you would have to do a lot of work yourself. You have to build your own server rack.
Server racks.
And you have to just make sure that the networking works. You have to make sure that the cybersecurity works. Your firewalls are all properly configured. You're so many details to get this just running a server right. And beyond that, I have to write my own identity stack. I have to write my own payment stack. I have to write my own database stack, and then build whatever application I'm building. So this is actually a huge bunch of work. And today, you would just say, go and integrate with AWS, use like a bunch of SaaS services in the backend, like plug and play with all of them. And then like you can just build the diff of whatever new thing that you want to build. Yeah. That's such a powerful enabler. And so many people like could now come and contribute and write code and just send it to AWS, and like they just taken care of. And so there was a lot of open innovation in the SaaS era.
Yeah.
And hyper specialization. Right? People build a software.
Unbundling.
Sorry? Unbundling. Like a massive amount of unbundling, right? Like you just find like a very narrow thing that you're most competent in. Like here is a real-time streaming data service for autonomous AI inference, or some like very, very, very specific thing.
But it's all those micro things are going to be more sci-fi because we're in crypto now. Instead of marketing SaaS, it's going to be some AI Oracle something.
Exactly. So even cooler, even more fun, right? So with this idea of SaaS as, you know, software as a service, making it open, making it verifiable, right, is what I think like, so that's really the two new things you get with the crypto, with decentralized trust underwriting it, is you can make it open, which is censorship resistant, live, all of it. Make it verifiable, which means if it says something, it is correct. Otherwise, there's economic incentives, other things to make sure that, you know, people don't do it. So those properties, if you add it on to the openness and verifiability, if you can add it on to SaaS, that's a huge like upgrade. So I had that mental model from like 3 years back. In fact, like our first white paper for EigenLayer, even before we knew about staking or restaking or anything, was actually called EigenLayer Unleashing the SaaS Era of Crypto. And, you know, we call it the SaaS era, but really the open innovation is what the main like driving value was, because I always had this theory of trust, decoupling trust and innovation. So that was there. And then, but the mental model for the rest of the space, like what is going on with rollups, what is going on with Ethereum versus other blockchains, what is going on with how rollups, and what is the role of rollups, AVSs, Ethereum, EigenLayer, like in this broader space, was not that clear. It was a kind of like a moving parts that I had vague ideas about, and I think they fit only like a couple of weeks back. So that's when I wrote that tweet. The first idea there is Ethereum is the verifiable internet or open verifiable internet, and it's because any statement made on Ethereum has been it's anybody can go and add new statements onto Ethereum, and all these statements have been verified, validated, and Ethereum chose this path of more permissionless innovation when it chose the rollup era, making itself more open. Now, it's not just one open verifiable system. It's a system of open verifiable systems. So each of the rollups then are basically making claims that are, in an open, censorship resistant, verifiable, provable manner back to this common system. So it's a system of open verifiable systems. And so a rollup, so if Ethereum is this like very open verifiable internet, on top of which I can now write a new application. And this is another thing that I was coming closer and closer to, is the best way to write any like consumer application is write it as a rollup. And it was just becoming very obvious, because you get all the benefits of being a single node kind of like a system, like a server, right? When you write an application, what you do is write a web server. But really, rollups are just open verifiable web servers. They're verifiable because they prove their state back to Ethereum, and they're open because they borrow censorship resistance and liveness back from Ethereum. So these two properties make it clear that essentially what you want to do is, when you're writing an application, you have to ask yourself, do I need openness and verifiability? And if you want it, just write it as a rollup. Like now I can suddenly start thinking about taking anything that's there on the cloud, asking this question, does it benefit from openness and verifiability? And then I should then be really writing it as a rollup on top of Ethereum.
I'm raising my finger like I'm in one of your classrooms asking a question. So maybe to double click here, I think we're going to go one layer deeper into the abstractions. So what do you see as a distinction? How do you think about what rollups are at their core? And I think, if 2 years ago we asked someone in crypto this question, they would say that there's going to be a handful of rollups. They are, secure, decentralized. They settle onto Ethereum with either fault proofs or validity proofs. There's going to be Optimism, Arbitrum, Starknet, whoever else. And if you're building a new application, your choice is really to deploy that smart contract system on mainnet or on one of these rollups. And now, more recently, I think we're shifting to thinking of individual applications as rollups and kind of like seeing the whole rollup construct as a much lighter weight thing. Why do you think this is clear now?
Yeah, I think there was never a stable equilibrium with a couple of rollups, right? Like that's just not a stable equilibrium, because why not they just be their own chains, or why would you have a common framework for like two rollups to interoperate? It's not clear. I think the way to think about a common substrate on top of which people are building these applications, and each application that needs customizability becomes its own kind of rollup. And but they all are on a common zone of trust that they interoperate without trust assumptions, right? So that's the metaphor of the open verifiable internet, enabling this communication across these rollups without taking trust assumptions. I think here is worth making one comment, which is that blockchains, there's a few people, for example, who index heavily on composability as the kind of most important things that blockchains provide. And when they normally talk about composability, they're all on a common, like same synchronous space. I think, so you can think of composability across these applications in two dimensions. One dimension is what is the time scale of composition? And the other axis is what trust assumptions do I need for composition?
Mm-hmm.
And I think the way Ethereum, so you can have trustless asynchronous composability across rollups. You cannot have trustless asynchronous composability across L1s. So to me, the app chain thesis doesn't make sense because each app chain is its own zone and it can't
its own trust zone. So you're like tapping into a piece of the terrain that you don't trust. That's kind of like dark terrain to you.
Exactly. Right. And why would that be like, the right architecture if instead I can actually create a zone which has a lot of trustless composability, but only asynchronously.
Right.
And then what happens is each application kind of goes on its own asynchronous zone. So in the normal mode, like I can just like go ahead and do my own thing. But when I am exchanging messages across these other systems, I can actually do so trustlessly, which is a huge, like if the whole benefit of the space is providing trust, then maximizing trustless composition bandwidth is actually the real thing. And you can never maximize trustless composition bandwidth synchronously because most of the applications in the world don't run synchronously. And it's a huge expense to run things synchronously.
Right.
So the right framework is the maximum amount of trustless composition bandwidth is going to be obtained.
Wait, what do you mean by most applications don't run synchronously? Are you talking about like even just
the application? No, most of the different applications
there's like threads. There's threads running and they kind of sync up with each
even
other.
Even inside a single like multiplayer game, right? There is rooms and there is scenes and like you.
So are you envisioning a world where a single application has multiple rollups and each of them are responsible for a thread within the game and they're communicating with each other? So it's not even one application, one rollup. It's one application, multiple rollups.
It could very well be like that. Exactly. So each service, which doesn't really need super fast synchronous composition, could basically be like its own thing. And like they're all like tapping into like this open verifiable common framework, and then they all like communicate with each other. So that's the first portion of the metaphor. Ethereum is the open verifiable internet and rollups are the open verifiable web servers. And then like in the open verifiable web server context, it makes sense to think of, is Apache web server going to win? Is Windows NT web server going to win? There are many instances of Windows NT web server.
And these are the AVSs?
No. Those are the Optimism, Starkware, ZK Sync. That's like, what code are you running for your web server? Are you running an Apache web server? Are you running a Windows NT web server or some other web server?
Is that like, could you virtualize the server logic as another piece of software? Like, could you implement a rollup node as an AVS? I think you could, right?
You can. So when do you build something as an AVS versus when do you build something as like, what is this? That's
the sequencer we're talking about here,
right? The
right?
sequencer that I'm talking about, exactly.
Yeah.
So I think there is a place for this like single node. I think architectures which don't have single node make me worried because you will never be as good as like a web application for the normal mode users. And so it's not going to be like as good as that, like whatever else you do, right? You'll never be as good as the kind of like the fun experience you have in scrolling Instagram or Twitter. You're not going to get that. If you don't get that, you're not going to win. So you have that while being verifiable. So the way I think about it is a rollup is, instead of starting with the blockchain, start with a single node and then see what you can prove about this single node. What properties, what elements of trust can I verifiably transfer? Oh, I'm running a rollup. I'm running this single node. I'm going to prove to you that I ran the execution correctly. Like that's one example of what I can prove to Ethereum. But you may also want to say,
and how do I do that if I'm the only node?
I'm the only node. I just create like a ZK proof that, for example, I'm running.
So this is ZK, using ZK proofs. That's how a single node is able to do this, right?
Let's just assume that the ZK proof world works, right? Like that. The other option is that I just have enough stake and then I make a promise, and anybody else who doesn't like it or got harmed by this claim can then like the Truebird or any kind of optimistic. But it is a single node. It's either making like an economic claim or it's making a cryptographic claim that it's doing the right thing. Now, but then you start realizing that you can only prove execution of deterministic, internally consistent virtual machines on this cryptographic proof. There are other elements of what it means to run a node. Like, are you censoring transactions in the fast mode? One question. Another question, are your Oracle inputs, if your sequencer also had oracles, are your Oracle inputs correct? So then you say, just like it is hard for me to build all the things I need in a web server myself, and in the cloud, I integrate with other SaaS services, which actually already have payments and databases and all this stuff that I can tap into. In the same way, for a web server, for a rollup, to verifiably prove to Ethereum that it's gotten the right Oracle input, it has gotten the right ordering guarantees, that it has gotten the right two-factor authentication, whatever stuff that it's doing, it has to prove back to the open verifiable internet that all those properties are holding correctly. It's difficult for me as an application developer to do all of these things. Also realizing that each of those things, once you know how to do an Oracle verifiably for a particular application, it can just be used by all the other applications.
And it's not your core competency. You want to focus on building what you're building, and you want to outsource the rest.
Exactly. And like Amazon did, like to build a bookstore, they built a cloud. To build a bookstore, they built a database. To build a bookstore. And that's exactly, we're already seeing that in blockchains with no place for those things to transfer. For example, in Cosmos, Osmosis is a DEX, is an application-specific DEX. They figured out that to actually run this application-specific DEX without MEV, you need to actually have threshold encrypted mempools. That's a thing that they bundled in with their app chain. But a threshold encrypted mempool is just useful for so many people. It should just be a service. So then you come up with this concept of, just like there are SaaS services that abstract away like certain aspects that are useful across many applications, there are AVSs that abstract away these elements from these applications. While building an application, you may realize, I need verifiable AI inference, so I need to build a verifiable AI inference. Build it as an AVS, so you consume it yourself, but also other people consume it. And when somebody else builds a better verifiable AI inference, you can switch to it, or you win the verifiable AI inference AVS. So this is the right kind of coordination structure in our view. So you have now the rollup, which is a verifiable web server. You have AVS, which is verifiable SaaS. And just like both the web server and SaaS services run on the cloud, you could have the rollup and the AVSs run on EigenLayer. But it's more important for the AVSs to run on EigenLayer because they pack this element of decentralized.
So there's you could run the AVS on-prem, and that would be if you bundle it in and you built it yourself, like you had the threshold encrypted mempool. But then there will be the cloud version of it, which is an EigenLayer, which is just a SaaS service that you basically install and run as a part of your stack.
This is our view of how future chains would look like. There will be no notion of a chain. Basically, a single server has a lock on how to integrate these different services. I subscribe to an ordering service. I subscribe to a finalization service. I subscribe to a bridging service. I subscribe to an AI inference service. It's just these services that are living here, and then you subscribe to some bunch of them, and then you prove aspects of your own existence and all these different systems back to Ethereum, and then now you're on the kind of verifiable internet.
Okay, let me retrace this in to make sure I follow. So a rollup, we're living in this, let's live in this future. I'm building a new application. I care about having verifiability and kind of tapping into building trust, doing this in the verifiable web. And so I instantiate my application as a rollup, and all that means is that certain parts of my application state I'm choosing to kind of like put onto this like verifiable blockchain. And I either do that with crypto economics and, maybe giving signed messages to participants and then posting something that they can dispute and take my stake, or I post ZK proofs. But in either way, I kind of like anchor my state onto this verifiable internet. And then, any kind of external things that this state depends on, let's say it depends on some price or some, some encryption thing, whatever it might be, I have to build a way to allow this to publicly verify, make it verifiable to this external, universe. And either I can build that myself, which is basically what building these peer-to-peer, incentive networks has looked like so far, or I can use one that has been built, in the context of EigenLayer as an AVS. And so this kind of forms the stack. I realize as I'm saying it that I'm kind of piecing this together much more slowly, but it does make sense to me.
Thank you.
It's a really powerful,
relatively new model, and I'm also explaining it for the first time. So
maybe let me ask some questions to flesh this out. So there's a few lenses we can take on this. One lens, which I think you've also talked about, and I think this also brings in EigenDA, because EigenDA is the first of these kind of like SaaS services that particularly a rollup uses. How do you think about, how does the economics of one of these rollup servers looks like? So they have revenues, they have costs and fees that they pay to these services. What does that kind of like accounting look like?
Absolutely. I think, again, we draw a lot of inspiration from the cloud. The thesis is that like working system work for a good reason, and you want to find like ways you can improve it, but you want to learn from systems that are successful. And one particular thing that I was, as you think about the economics of running a rollup or running this verifiable web server, was that in crypto, a lot of our systems are priced instantaneously. Like, I need to use block space. It's just like a just-in-time auction for block space.
Mm-hmm.
And it's very different from how like businesses think of themselves, right? Like they want to have, so a famous story back maybe in 1980 would be the Ray Dalio from Bridgewater Associates trying to help McDonald's like have a fixed price burger because they can hedge futures of soy or chicken or whatever.
Mm-hmm.
And
I think he talks about this in Principles, right?
That's correct.
Yeah.
And so it's such an important thing to build a low cost kind of business. Is you need to control input costs and have that not only reduce variance, not only like reduce the average, but also reduce variance is very important, because otherwise I'm selling seats on an airplane where like jet fuel price is fluctuating on a weekly basis. So there are two ways to do this is like futures contracts where you kind of like hedge against futures. You need some counterparty to do that. The other possibility is just have long-term contracts, right? So like a major airline would have a contract with the oil producer natively for so many barrels of oil per year. And that, I think, simply doesn't exist in pretty much any blockchain. I would say like an exception is Polkadot has like 2-year parachain auctions where like you can, once you become a parachain, you have 2 years of block space allocated for you. So other than that, but this was a very important insight that actually, if you want to just build your applications, I think one of the things that we miss in the space is a lot of people throw a token on top of something and then they think it's a business model, and it's not, right? And it is the thinking carefully about what is the cost basis, what is the input cost, what is the value proposition, how do you make sure that the value is higher than the cost. That's the elements of a business model. And one thing we think about a lot is how do we enable somebody who doesn't want to create a token or whatever to still participate in decentralized trust? Because the main thing is the decoupling of trust and innovation. So which means like I should be able to just run an open verifiable business, right? Like an open verifiable web server rather than this closed non-verifiable web server, and still make money off it. So one of the problems is that you want to reserve. So if you think about like how you deal with the cloud, you can have like reserved instances where you reserve some number of like nodes for just yourself for a 1-year period. Or you could also have spot instances, which you just like spin up and it just like runs for some time. And you want to mimic that in crypto. So spot instances already exist. Like you can just buy bandwidth or like compute on the fly on Ethereum on any blockchain. EigenDA is the first one that offers reserved data bandwidth. Means you come in as a rollup and say, hey, I need like this much bandwidth for this year, and there's some pricing associated with it, and then you just pay for it. Now you have a contention-free access to that data bandwidth. Nobody else can write data in that space. Only you. It's just for you. And so that means now you have guaranteed fee certainty. So the next 1 year, this is your price, this is your lane, no contention. Yuga Labs cannot create a new Bored Ape drop and like drown you, or CryptoKeys or whatever the new version of that. Not going to happen. You have your own thing. I think this is really, really important. So to have cost certainty. So EigenDA is built with this model.
What is that cost denominated in?
Oh, a V ETH.
But then is it adjusting based on the price of ETH, or is it going up and down?
Okay, good question. So that brings us to another innovation in the economics that we did, which is that this is reserved instances which are, there is a native rate card, which basically says, if you do this much in ETH, then you can access this much data bandwidth, because our own cost basis is denominated in ETH. Because EigenDA is using ETH staking, so it's like it's a certain bips on top of that. So our own cost basis is denominated in ETH. So the native pricing is in ETH. But you could come in and say, hey, I'm a rollup. I want to pay in my own native token. I don't want to pay in ETH because that's an exchange rate risk for me.
Right.
Because reservation is a long-term activity, not an instantaneous activity. You can actually whitelist the EigenDA can actually like whitelist whichever tokens to pay in a fixed fraction of their own inflation rather than in ETH. And so this aligns kind of like the Ethereum broader ecosystem with the rollups native economy. So it's
fascinating. So it's like the equivalent of paying for a SaaS service with your equity in some ways.
Yeah, I think so. Another way of thinking about it is like DA is now offered in this world as a basic good for which you're taxing on like your, value, right? Like, so you're creating a new country and then you say, oh, data availability is a kind of fundamental right or basic good that I'm offering to anybody who opts in. But they have to commit to pay like X% of their economy to it. So that's the trade.
Yeah. There is a way in which like these are going to be overlapping stakeholder bases too. Like it's, you know, it's like an amorphous, it's like the Borg that's forming, right? And they're not, it's, you know, when you peer into an ecosystem and all the founders of the different projects have angel invested in each other's companies. It's kind of something similar, but this for this cloud, because they're taking revenues denominated in the other services as tokens, right. And therefore they potentially want to see each other succeed in a way also.
That's exactly right. So, and you know, there's already this notion of airdrops and giving to the community in one way or the other, and this is just one more dimension of like using the same mechanisms to actually create alignment rather than the opposite, which was counter alignment, which was, I can only pay you in ETH, and therefore like I have to sell my tokens at this rate and take exchange rate risk and do all this stuff to actually pay you back. So we identified that as a friction and then like realign. Our vision is, Ethereum has this metaphor of being the infinite garden. Right. And
I love that metaphor.
I love it too. But we have a one-up on it. I don't know. Maybe
what is it?
It's an Indian thing for me. But I think the even better metaphor is it should become the infinite forest. Because in a forest, you don't know where it ends, where one tree ends, where the other tree begins. Like there's no gardener who's kind of like keeping this whole place in its own check. It's just emergent. It's emergent and it thrives and it kind of like automatically like weeds out the things that don't thrive. It's not curated. There is no, So I think the forest is a better metaphor. And an important thing about a forest is, in natural forests, you don't really know like the forest is ending here and it's something else is beginning there. It's all like really smooth and that is how we are expecting right now. Like each chain is kind of, it's either separate or together. And instead in this forest, they're all like tightly interconnected. Like the whole economy is very tightly interconnected underneath.
Yeah. I think that the reason the metaphor of the garden makes sense to me is that, especially in the early days of these ecosystems, like there could be some variant of weed that starts growing up and just takes over the whole thing, And so and I think that the role of the gardener, you could think of it as, say, the one way to think of it could be the organization or the foundation who created the thing. But I think a better way could be like the kind of like collective social, social consciousness or expectations or social consensus that exists. And you're like helping this thing grow in a particular direction and not in other directions. And over time, I mean, the garden converges on a forest. That's like the best version of it, right?
Yeah, exactly. And that's exactly, I think, what is happening to Ethereum is that it's all, I think it's just already that it's descriptive. That's already a forest, right? It's not.
Yeah.
Yeah.
So when you think of a rollup, like rollup as this new web server, are there certain kinds of applications that make sense to build in this world? Like are they kind of like distributed market-based applications? And then second question is, what do you think, what is the fundamental like business model of this kind of application or a rollup? Is it fees? Is it like scarce block space in some sense? How do you think about that?
Yeah, I think my analogy is still back to the cloud. Cloud space is not like a thing, right? Cloud space just stretches to accommodate demand. And that's, I think, how I envision the block space to become. It just stretches to meet demand. There's a certain cost basis, you have to pay for it. And because maybe it's aggregating across all these different applications a little bit, it is still enough to be interesting. But the core application revenue model, which will firstly move from every transaction has fees, right? One of the things we talk about in the space is how blockchain opens up it is more democratic, it's more permissionless, it gives everybody access, it's open access. But I think blockchains are not free to use, and they are non-discriminative between any two people paying the same price, which I view as a major failure. Two people paying the same price means like a bot, an MEV bot, can bid up the price against a person who's simply not able to pay more, but actually can benefit from using these services.
Mm-hmm.
And I think it's because the only objective entry control mechanism in blockchains is fee. Like there's no other objective one. And so I understand that. And then that's like, okay, that's the kind of trade-off. But rollups can bring you the best of both worlds. Rollups can say, as a web server, I have subjective admission control. Like you prove to me you're like a real human being, I'm going to make it free for you to use it. But also, if you pay a certain fee, you're guaranteed that your transaction gets included, because you can force include your transaction either from L1 or a data availability layer or whatever. So I'm going to give both the worlds, that there is a subjective entry control which can be free. There's an objective entry control which is priced. And because I am the rollup web server who's actually like has some position in the system, but my position is not too heavy because you can circumvent me. I cannot do false stuff, but I still have some position. Means that I can have business models which are very similar to the internet, but now with the open verifiability properties added on top. And one of the things that it like absolutely opens up is the ability to have wallet-free transactions. Like, I should not need a wallet. So a lot of onboarding into crypto is blocked by the wallet. And most of the times, imagine a crypto social network or other things. Like I should not need a wallet for most of this stuff. But I need the power of crypto because I want user-governed networks. I want me to get paid if I need it. I want to have the ability to exit, without being tied into like a service provider. I need all these properties which are powerful and like endow like more sovereignty to the individual. But the rollup as a web server basically empowers me to have this subjective entry control in addition to objective entry control. So which means now for the first time, I can make it actually completely free and only even I sell NFTs if you play my game. So only
I could auth like in the actual website, like there is a website somewhere. Someone goes on there. I as the rollup operator, sequencer, I'm operating this website. I have someone auth with whatever social login that I want. And because they're a person, I tell them this is free. And there's no notion of them even having a wallet. There's no wallet in the browser. There's nothing like that. And I just handle everything. I still, there's still potentially transactions being sent internal to the system, but even the internal state of the system isn't necessarily legible to the entire world. It's only like parts of it that I choose to compress and snapshot and give access to.
For example, I may not, I think you inherit the openness and verifiability on the things that you prove back to Ethereum. Right? Like that's the places that you inherit the openness and verifiability on. The other ones you don't. And what state needs to go on the chain and what state doesn't is also an interesting architecture problem. And like not everything needs to be open and verifiable. But even if everything was open and verifiable, the entry control mechanism doesn't need to be. Right? Like, I know it's Sina, I'm going to let him in. Like it's an absolutely valid thing to do. And as a rollup operator, as long as I can make sure that on an average over this year or several years, I'm able to, sell more artifacts than I am able to like actually, I'm paying. then I'm solvent as a business. So that's the kind of business models that are like total unlocks in our view. And they need both this cost determinism on the one side, the UX improvements of using like wallet-free onboarding on the other side, and like native powers. For example, one of the things that would be missing if you don't make one part of it open and verifiable is that I was using this web server with my social login, and then now this web server is like not behaving well to me, and I want to exit with my sovereignty into a wallet. And then I need some mechanism to do a two-factor authentication on me and make sure that it is me, and that needs to be open and verifiable. So that's an AVS. We have these things called TLS notaries. We have a few versions of these building on EigenLayer. Like some TLS notary would come and notarize me, and using a trusted execution environment or a secure multi-party computation or whatever complex thing, and then it would then give me my ability to move all my data and thing into my a new wallet that I denominate, or a new account, and denominate a new operator for me. So I think there is like a huge design space here that I think is barely even touched as of today.
It's wild that this many years in, it feels like we're still opening up like entirely new landscapes.
Yeah, it is crazy. And because, going back to it, this shift of the decoupling of trust and innovation, or the decoupling of like verifiability and privacy, these are so basic. Like, it's just at the very fabric of civilization, in my view. And so obviously that means that there's so much to be done.
Yeah. Do you mind if we spend the last few minutes talking about some more personal topics?
For sure, yeah.
So I guess one thing I was curious about is that in your former life, you were an academic. And a lot of the ideas we're talking about today, like, the beauty of the role of the academic is that you can sit and work through the ramifications of these ideas and how they can be architected, and, what the affordances are and all of these things. And you've stepped into this operator builder role, and not a mild version of it, right? Like we were saying in the beginning, like building something that's like pretty intense and demanding. What's this been like for you?
It's
how are they different? Like how do you find yourself kind of being differently in your mind
I think if I were doing a different startup or a different kind of company, I may actually be a very bad fit for it. I'm just uniquely fit for what I'm doing because it's just aligns with my way of thinking and my worldview so much. I was in academic as an innovator because I care a lot about these non-zero-sum games and creating something new and useful. And innovation was kind of my limited way of like contributing to it. And the way I think about my own role now is, how do we empower anybody to innovate? Like, that's what kind of fundamentally drives me. And in some sense, my own framework, the ways of thinking would make it very hard to compete in a zero-sum, aggressive, competitive market. Like, I'm not well suited for that. I'm suited for precisely the kind of thing that we're doing, which is actually to encourage more coordination, try to create like a system of coordination on which people can do innovation, right? And we were talking earlier about like bringing the ideas, the computational resources, the capital, all of that together to actually create new and valuable services. And so I feel like I'm kind of in my zone
of genius,
and my zone. I don't know if I want to call it genius, but definitely in my own.
Well, in your zone of genius, anyone has that.
Absolutely.
Yeah.
Because it's a very, very strong fit to my values, to what I believe in. And because, my own imagination of what it feels like to do a startup would have been very, very different. It's like, I have to give up on my values to go do a startup or something. Like, that's absolutely not how it feels. It feels exactly the opposite. It's like a doubling down or even 10xing on like my own values. So that part feels good, but there's so much to learn on the other side to actually like build a project, whether it is a community, whether it is inside as a company, right? This is, there's the complexity of generally the particular marketplace that we're building, but there's also so much complexity in general in building a crypto project because you're building a community while building a company. Building a company is already like really, really hard. And building a community is also its own thing. So you're doing these two things together. I think the few things I learned, actually, I tried to do a startup like 5 years back in the blockchain space, trying to build a blockchain, for example. And that time what we did is it was 3 professors, and we tried to recruit more people like us. Like everybody was basically just more of the same. And I know they're all very good people, but we all think alike. We have similar strengths. This time, when I did the startup, I'm absolutely not doing that. I'm doing the thing where we want to find people who are totally different, each one in their own zones of genius, which are very different. And how do I build a team which is like that? So that's how our team is. And from the outside, a lot of people only know me or maybe like 3-4 people who are mostly in outward facing roles like business development and strategy, whereas that's a phenomenal thing. I mentioned our CEO, Chris Jury, earlier in the conversation. And as an example of a very different type of personality who's built companies, scaled them, understands all of that stuff while still having similar values. And so we have these common values and principles that people are aligned on. But in terms of skills and personality types, we have so many different types of them. So now, my own job as an entrepreneur or like a startup person is making sure we get really, really good people across these different zones of genius. That's number one. And then number 2, making sure they can work well together, which is much easier when it's a homogeneous crowd. It's much, much more difficult when it's a heterogeneous crowd.
Is this something you feel like you honed in your academic life with like looking for PhD students, or because I've also noticed I've noticed this about the team also, that it's a powerhouse, and there's many people who I've known over the years in crypto who are working on EigenLayer now. Like what have you looked for in people?
The main hard thing is not how we recruit people now, which is, people know us, there's like some name brand, all of this stuff. How did we do it like on day 0 when we had nothing? I think that's the really, really, really hard thing. In fact, when I did the startup, our philosophy was I should put in my own money. Like, if I'm not even able to put my own money and go raise money, it feels like there's a moral hazard where like you want to just burn somebody else's money, but not touch your own. So I said, okay, I have to like commit a significant portion of my own money before I go ask anybody else. And so that basically means also that it's very difficult to recruit. It's my own money because there's no certainty that this will last for any amount of period. So the only type of people you can recruit are missionaries, like people who are kind of aligned with the mission and already kind of in it for the long term. So thankfully, we got a small group of that. Chris Jury was one of them who joined maybe 6 to 9 months after we started. But the initial cohort was mostly like, it's around the university ecosystem, like a few people from the university. There was a high schooler who was just going to start at the university. There were like, a friend who was a product lead at a company who quit and joined us. Things like that, like, is mostly a university and personal ecosystem. And then after that, that was easier because it's people you know from before.
People you know.
But after that is really hard. Like the first outsider who is missionary, and wants to join is really, really hard. And so that was interesting to go through. But one thing that missionary culture attracts is they self-select
more missionaries.
Really, really good and also missionary in that view. So I also have a few anti-cells, when there's a cell call that usually execs do. I also have anti-cells in the call, which is things like I would say, hey, if we have to make a trade-off between what is net good and what is more profitable, we'll just choose what is net good. Some people are like, okay, this guy's crazy, I don't want to work with him. And those kinds of things help, and it builds this self-selection over time. But as an organization, it's still very hard. It's hard to run and maintain an organization which is highly agile, operates like a single team, which seeks high impact per unit action. All of these things are not easy. It's difficult.
That's a good
You're
metric.
still struggling with all of those things, like many other organizations.
Yeah. Cool. Well, this is a good place to bring it to a close. Thanks so much for taking the time.
Thank you so much, Sina. Really enjoyed the conversation and looking forward to have more.
Hey, I'm going to make a small ask here. If you've been listening to these conversations and want to support what we're doing here, I would really, really appreciate if you could leave a rating and a review for the podcast wherever you're listening to it. This might seem like a small thing, but it will really help other people also discover the show. Thank you. I'm grateful to be able to do this and look forward to being here together again soon.